Day 45, page 935, problem 68. Here's a little bit of a challenge problem. It's implied, it's not completely obvious that this is a diverging mirror, but I'm assuming it's a diverging mirror. You can get into a little conundrum with the negatives here, but I'll try to be consistent with a diverging mirror, and we'll see how this works out. In the blue circles, I have the basic equations. The focal length of any mirror is negative r over 2. Magnification for any mirror lens is negative s sub I over s sub o. And then the lens or mirror equation in generic form. In the upper right-hand corner there, I've solved for s sub I. And basically, it's all algebra from here on out. You're going to take those top two equations and plug into the lens equations. In other words, if I plug in for f and then for s sub I get the following transformation of this lens equation. It's 1 over the negative r over 2, I've gotten rid of f, equals 1 over s sub o, which I didn't need to get rid of because I see that that's what I have to have in my answer. I want s sub o in the answer, r in the answer, but I cannot have s sub I in the answer. That's why I solved that magnification equation for s sub I, so I could get rid of that. It's 1 over negative m times s sub o. The rest is algebra. Okay, and there's probably faster and slow ways to do this, but let's try to clean this up a little bit. On the left-hand side here, 1 over negative r over 2 is the same as negative 2 over r. Equals 1 over s sub o plus, or you could even say minus, 1 over, let's just do that. Let's just say minus 1 over m times s sub o. All right, I'm going to move the term with the m to the left and the term with the r to the right, so that I end up with all positives, and I'm trying to get the m isolated anyways. 1 over m s sub o equals, 1 over s sub o plus 2 over r. One thing you can do here right now is multiply all the way through by s sub o. I'm going to do that and come back up here to the left. Multiply all three of those terms by s sub o. So on the left-hand side there, you'd get 1 over m equals 1 plus 2 s sub o over r. All right, you can maybe see this taking form now. On the left-hand side, I'm going to have 1 over m equals, now I'm going to add these two terms on the right here, but I'm going to change the 1 to an r over r. I'll do it in 2 steps. So I make that r over r plus 2 s sub o over r. Now I can add on the right, I end up with 1 over m on the left still, equals r plus 2 times s sub o all over r. And all you do now is reciprocate everything, flip everything on both sides, and you have what you want to prove. You have m equals r over r plus 2 s sub o, which is the same as 2 s sub o plus r. Doesn't really matter which way you write it, because the commutative property of addition, and voila, works out. And just to recap again, with these symbolic problems like this, start with known equations and then basically use algebra. So then there was 3 known equations, and we just started plugging things together, and sometimes you go down on a dead end, you have to start over, but just play around with the algebra, and if they typically say you can prove something, it probably can be done, and in this case it is verified. Sometimes you got to come up with a new finding on your own, but basically it's the same process every time. Take the known equations and then just crunch the algebra.